Okay, so our objective today is to understand how to simplify, I do that all the time, simplify products and quotients of radicals. So embedded in that meaning, in that title, is I'm going to teach you how to multiply with radicals. I'm going to show you how to divide with radicals, and then I'm also going to show you how to make sure that you've reduced everything that needs to be reduced. Okay? So this comes out of 2 lessons. The lesson on products is 11.4, and the lesson on quotients is 11.5. That's why I have 2 different pages of homework. The 496 goes with the products, and the 501 goes with the quotients. Okay, so we have been working with a particular rule that if we are being given a radical, that we need to simplify it. And the one thing we've been looking for is, can we find a perfect square factor inside of that radicand? And if we can, then we're going to take the square root of that. That's actually only one of the 3 rules when you're supposed to do simplest radical form. So I'm going to call them the simplest radical form rules. And the first one is the one that we've practiced the most, and it says the radicand, that's the guy under the radical sign, has no perfect square factor other than 1. You can always leave behind a 1 because it's not going to change the value. Okay, the second one, rule, we've only used a little bit, but we have actually used it. There are no fractions. Oops. Under a radical sign. And we did that a little bit. I can't remember which homework assignment it was, but I remember there one being like the square root of p to the 6 over 400. And you had to take the square root of the p to the 4 or 6, and you had to take the square root of the 400. So you took square root of each of the parts. And that's kind of how we can make sure we can try to get rid of these fractions that are under radicals. Try to take the square root of the numerator, try to take the square root of the denominator. Now let me go back and add one thing to each of these. On the radicand has no perfect square factor other than 1, is remember that if you have a product under the radical sign, that what you're looking for is the square root of each of the factors. And that's where we were pulling out a perfect square factor. And on this one that we just talked about, no fractions, if you do have a fraction under the radical, remember you can just try to take the square root of the numerator and the denominator. Now, when we did this, and I can't remember which night it was, and we took our square root of p to the 6th or 8th, whatever it was, divided by 400, and we were able to take the square root of the numerator, and we were able to take the square root of the denominator. Tonight may not be the case. Tonight there may be leftovers, and then that brings us to the third rule. And the third rule says there are no radicals in a denominator. So if you try to simplify and you're left with a radical in the denominator, I'm going to teach you what you need to do to make it go away. We can only have what we call rational numbers in the denominator. Okay, so let's talk about this notion of clearing a denominator of a radical. So I'm going to give you an example of what this might look like. According to these rules, there's no perfect square factor other than 1 in the radicand. 2 has no other perfect square factors. There's no fractions under the radical. No, I have one number. The numerator is not under the radical. But I do have a radical in the denominator. So what could I do to what we call rationalize the denominator? And remember, to rationalize means to make it a rational number. A radical is an irrational number. I need to try to make that radical 2 be something that is considered rational. So what do you think we could attempt to do to get that radical 2 to stop having a radical sign? Trent? Okay, if I multiplied by the reciprocal, then I'm multiplying the numerator by one thing and the denominator by something else. So now I'm actually changing the value of my fraction if I multiplied by its reciprocal. So that's not going to work, but at least that's a good idea. That was a good try. Pratt, what do you think?
Square the entire fraction.
Okay, again, that means I'm multiplying 1 by 1 and I'm multiplying radical 2 by radical 2, which again, I've now changed the value of that fraction, okay? But you're onto something good there, I think. Joshua?
Multiply both the number by 2 and so.
If I multiply the top by 2, that gives me 2. If I multiply the bottom by 2, I get 2 radical 2. So I still have the radical. But you're onto something interesting there. Luke? Okay, you got to put your hands down so I can actually read your lips. You're going to, okay, he said squaring, and we said that's actually changing the meaning, because if I don't treat my numerator and the denominator exactly the same and multiply them by the same value, then I'm going to change the actual value of the original fraction to something new. Okay? Jason? Just by radical 2? Then that's multiplying by the reciprocal. That's not the same value. That's going to change what this fraction equals, because basically you're going to tell me that 1 over radical 2 equals 1. Okay? And because that's what you get when you multiply by a reciprocal, is you always get 1. So that's not quite right. We're so close. So close. All right, let's just focus in on this. How do I make radical 2 stop having a radical? Okay, so what you do is you multiply it by itself. If you want to treat the fraction the same, then what are you going to multiply the numerator by? Nope. You got to multiply by what you multiply the denominator by. So radical 2 over radical 2 equals what? 1. So I'm not changing the value of the fraction, I'm just changing its appearance. Okay? So when you rationalize the denominator, you're going to multiply numerator and denominator, by the radical in the denominator. Now there's some options behind with this that you could multiply by different things, but this in general is a process that will work. And by the denominator. So we have to treat denominator. We have to treat both numerator and denominator the same. And we have to get rid of the radical by multiplying by itself. So that's what we call rationalize the denominator. And I've seen that written on tests. Jason? I've seen that written on tests in that fashion. It isn't how do you get rid of the radical in the denominators, how do you rationalize the denominator, okay? So what happens is you get radical 2 times 1 is radical 2 times itself is 2, and now I don't have that radical in the denominator anymore. I don't have a perfect square factor in as part of the radicand, and I don't have an entire fraction under the radical. So it meets the 3 rules for simplest radical form. So the last thing I'm going to say in that we're dealing with fractions is, what do you know you always have to do before you can say, yep, I'm done with this fraction answer? Which means, always reduce fractions to lowest terms. Okay, always, always. Now, what we just talked about, simplest radical form, is just dealing with the radical part, but we still may have fractions that we can reduce. So that's this next piece. So let's go through a variety of examples. Directions are going to say simplify. And simplify means do all the math that you can do until there's no more math to be done. So you do one thing, you may not be done. You do one thing, you may be totally done. So first one, I have radical 2 times radical 20. So what we said is when we're multiplying radicals, since they're to the same root, we can put them together under the radical sign and do the math. So what's 2 times 20? So now what I have is radical 40. And now I look for the greatest perfect square factor of 40. What would that be? 4, and his partner would be 10. The square root of 4 is 2, but I can't take the square root of 10, so I get an answer 2 radical 10. No perfect square radicals left underneath in the radicand other than 1, and then the other 2 rules deal with fractions, and I don't have a fraction. So that one is done. Okay? All right, let's try another one. 3 radical 8 times 5 radical 2. All right, how do I handle this one with coefficients and radicals? How am I going to do that? Armand, what do you think?
Times the coefficients times each other, then the radicals times each other.
Very good. We're just going to pair up outside with outside, so coefficient with coefficient, and inside with inside, radicand times radicand. So we've got 3 times 5 on the outside and 8 times 2 under the radical. And then we just do our math. 3 times 5 is 15. 8 times 2 is 16. And then we look, can we do anything with square root of 16? Okay, what is it? So we get 15 times the 4 we got when we took the square root of 16. And 15 times 4 is? And there's your answer. Okay. Bottom line, what work should be shown? Everything from 15/16 down. Okay, Jason, stop. Number 3, how would I deal with this multiplication problem? 3 over 20, the radical 3 over 20 times radical 1 2/3. What do you think's an issue with this one we're going to have to tackle? Lexi? Yeah, we can't multiply a fraction in a mixed number, so we need to have 2 fractions. They're both under a radical sign, so we can put them together. So remember how you do change from a mixed number to an improper fraction? You multiply the denominator times the whole number, 3, and then you add the add the numerator, 2, so we get 3 plus 2 is 5. And so this becomes 5 over 3. And then what we do is as we would with any kind of fraction problem, see if we can do any cross-canceling. So 3 goes into itself once and into itself once. 5 goes into itself once and into 24 times. So now I'm left with the square root of 1/4. Now this breaks rule number 2, which says you can't have a fraction under the radical. So then we're going to think about this as its parts. Square root of the numerator over the square root of the denominator. What's the square root of 1? 1. What's the square root of 4?
2.
And lucky for us, everything came out and we have rational numbers. So we didn't even have to try to do rule number 3 yet. Okay. All right. Everybody good? Next screen. Number 4. What if I told you to square a radical? What would we do on that one? Go ahead, Arma. What do you think? How would I distribute? What do you mean by that? Okay. Larshberg?
Distribute the 2 to the 2 and the 7 radical, and then that would do it radical just times the point after the number.
Okay, so tell me what I would be writing. What would it look like if I, in my head, was doing this distribution of that 2, that exponent 2?
Distribute the 2 to the 2 and then 7, and so that would be 4 for the 2, so 2 squared radical 7 squared.
Okay, so that means you're squaring both p's. Okay. And you said 2 squared was 4, and what did you say radical 7 squared was?
Well, when you take the radical of something,
Uh-huh.
it's 1/2 the number, so if you have it squared and
Uh-huh.
it's 1/2, then it would just be 4 times 7.
Right, it would be 7 to the first power, because 1/2 of 2 would give you 1. So we're going to get 4 times 7, and that answer would be 28. Now, an alternative to that, if you were confused what to do, you could just expand it out and write 2 radical 7 times 2 radical 7. And use what we've done before, where coefficient times coefficient, radical times radical, and get the answer that way. All right, let's try another one. What if I asked you to take radical 5 times the quantity radical 5 minus radical 10? What would I do here? Emily S.?
You would distribute the radical 5 to the radical 5 and the radical 10.
Yeah, it's just a distribution problem. So you're saying I'm going to multiply that radical 5 times the first radical 5, and then I'm going to multiply that outside radical 5 with that radical 10. Well, what's radical 5 times radical 5? You get radical 25, or radical 5 squared. Both would work to think that way. And what do I get when I multiply radical 5 times radical 10? Radical 50. What's the square root of 25? 5. Ooh, I can't take the square root of 50, so can I simplify that? What's the greatest perfect square factor of 50? 25, and his partner is 2. Okay, so I'm going to actually take this guy and drop him down a little bit. So square root of 5 is? And then I have square root of 2. Can I do anything more with that problem? Okay, let me ask you this question. Could I do anything more with 5 minus 5x? No. In order for me to combine a number by itself and a number that ends in a variable, they have to have the same variable, so I couldn't combine them. And the same thing is holding true with these radicals, which, by the way, tomorrow we're going to deal with adding and subtracting with radicals. So I'll be honest with you, this answer, this type of answer, is very typical of what we see sometimes in geometry class, where we take something and then we subtract a piece of it, and sometimes the piece has radicals involved in it, and so we get a mixed answer, but that's just what it has to be. Okay? What if we get a little bit bigger and we want to multiply radical 2x times the quantity radical 8x minus 3 times radical 12x squared? So now we have a lot more that we have to contend with. So I'm going to kind of break this down a little bit more than we did on the last one. So radical 2x times radical 8x is going to be radical 2 times 8x. And then there's a minus and a 3 on the outside. And radical 2x times the negative, or times the 3 radical 12x squared. Underneath it's going to be the 2x times the 12x squared. So here I get 16x squared minus 3 times radical, and I get 24x cubed. Can I take the square root of 16x to the squared? Yeah, perfect squares. Square root of 16 is 4. Square root of x squared is x. And then minus 3. Ooh. Can I take the square root of 24? No. Can I take the square root of x cubed? No. Oops. Actually, I can't, of x cubed. Okay. All right, so what's the greatest perfect square factor of 24? 4, and his partner is 6. You take the square root of each of those. And how do I split up the x cubed so I can take a square root? Anybody? Okay, so I take 1 out, and I have the largest even amount left behind. All right, so I still have that 4x. I still have the 3 after the subtraction sign. Now I'm going to take the square root of 4, which I can do, which is 2, and take the square root of x squared, which is x. And then what's left behind is a 6 and an x. So they're going to stay behind in the radical. So altogether, I get 4x minus 6x radical 6x. Can I simplify that any further? You could factor out an x and a 2x, but here's the deal. The reality is you can't do 4x minus 6x because it isn't 6x. It's 6x times radical 6x. This is as if saying 6xy. Can I take 4x and subtract 6xy from it? No, it's the same idea. They aren't like terms. Okay? All right, let's talk about those fractions, and let's deal with some of those. All right, so sometimes you are given problems where they've already split it up for you as the square root of the numerator and the square root of the denominator. But you run into a bit of a hitch. Can you take the square root of 15? Can you pull out any perfect square factors from 15? Can you take the square root of 3? Can you pull any perfect square factors out of him? So the only thing that you can try is to rewrite it as a fraction and simplify. What's 15 divided by 3? And there's your answer. So sometimes that's the best you can do, is to reduce the fraction to lowest terms. Sometimes you might get a square root, and sometimes you may not. Okay. Well, the bottom line is I couldn't leave it like it was originally, and I couldn't leave it like it was in the middle because this rule 2 says you can't have fractions under radicals. Okay. So you still have a radical. So if you have a radical over a radical, you need to see if you can look at it as one radical with a fraction inside, and then if you can't do anything, you have to try to simplify because you can't leave that radical there. So we'll talk about all these different what-ifs. Okay. All right. Joshua? No? Okay, we'll probably answer all of your what-ifs. Okay, so here's another one. They've already split it up, and they said square root of 8 divided by square root of 72. And grant you, is there a perfect square factor of 8? Yeah. How about 72? Yeah. And we could find them and pull them out. But what may happen is that we may have some stuff left behind in the radicals still. And we may be able to do some things with them. So generally speaking, the best way to tackle this is if you notice that those two numbers have anything in common, they're both even, make them one fraction and reduce them first. So what do 8 and 72 have in common? They have an 8, right? 8 divided by 8 is 1. What's 72 divided by 8? 9. Now what we're going to do is turn this back into each numerator and denominator under a radical. What's the square root of 1? What's the square root of 9? 3. And there's your answer. All right, let's try another one. Ooh, 21 radical 48 over 7 radical 3. So what's interesting is both of those values have coefficients. Both of them have radicals. So what if we kind of sectioned off the coefficients from the radicals? So that would give us a 21 over a 7, and then we can make one big radical over here of 48 over 3 and see if that helps. Well, what's 21 divided by 7? 3. Can I simplify 48 by 3? How many times does 3 go into 48? 16. Okay. Can I take the square root of 16? Yeah, what is it? So I have the 3 on the outside times the 4 from the square root, and I get this answer of 12. So here I am with a double radical answer, beginning problem, and I end up with no radicals in my answer. Okay. How about this one? The fraction 2/3 under the radical. Can I simplify that? No. But I have a rule that says I can't leave a fraction under the radical. So the only thing I can try is to take the square root of each, the numerator and the denominator. Can I take the square root of 2? Can I take the square root of 3? Okay, well this puts me in a big quandary because rule 4 says no radicals in the denominator. So this is the time I'm going to have to get rid of the radical in the denominator. Notice that it didn't say you couldn't have radicals in the numerator. If that was the case, most of the answers we've been getting on homework would be impossible. So what am I going to do to get the radical 3 to get rationalized? In other words, to get rid of the radical. What did we say that we were going to do? Armand, do you remember?
Multiply the radical 3 to the radical 2 and the radical 3.
Okay, good. So I take that denominator and I multiply top and bottom, both numerator and denominator, by that radical 3. Why? Because I want that value to equal 1. This equals 1. What that says is you're not changing the value of your answer, you're just changing how it looks. Like, I'm going to be putting on weight because I'm a lazy slug and not working out. I'm still going to be Miss Rosner. I'm not going to change my name to Jack Spencer. Just not going to happen. Okay, still going to be Miss Rosner. I just more of me to love, right? Then I'll go to the gym, hopefully, and then there'll be less of me to love. Okay? But don't love me less, right? Okay. So, can I multiply radical 2 times radical 3? What do I get? Yeah, I can multiply radicand with radicand. What's radical 3 times itself?
9. Radical 9.
Radical 9, which is 3. So one of the things I want you guys to understand is when you multiply a radical by itself, what is the answer?
Itself.
Yeah, so radical 3 times radical 3 is 3. The radical's gone. That's the whole point behind this. Now, can I simplify this fraction?
No,
Why not?
because it's a radical of 6.
We've got a radicand, which is underneath the radical. We've got a 3, which is outside a radical. They don't communicate with each other because they're in 2 different positions. All right, down to the last 2. 15 over radical 5. So this one's odd because only one number is under the radical. Can I take the square root of 5? Does it have any perfect square factors? No. Rule 3 says you cannot have a radical in the denominator. So what are we going to do to make that denominator not be a radical anymore? Give you a little hint, nothing different than what we did on the last problem, right? Yeah, and how are we going to rationalize this one? Amy?
Multiply the numerator and denominator by radical 5.
Very good. So in the numerator, we have 15 radical 5. Remember, radicals cannot compete with radicand, so they just stay out there. And then radical 5 times itself is? But I'm going to tell you that answer is not, it's not right. Why not? Brett?
You have to simplify the fraction.
If you notice, we have 2 coefficients. They happen to have a factor in common, so we simplify. What's 15 divided by 5? 3. So my answer is 3 radical 5. Okay? All right, here comes the doozy of the day. We have 1/3 radical 1/4, and we want to multiply that by 1/4 times radical 3/10. All right, well, we've done problems like this, maybe not all with fractions, but we've done it. So we said before, hey, let's just multiply coefficient with coefficient. So we're going to get 1/3 times 1/4. And then we're going to multiply radicand with radicand. So we have 1/4 times 3/10. Okay? So let's see, that gives me 1/12 radical 3/40. Oh, you know what? I did something wrong. Yep, I did. Let's go back. This shouldn't be 1/4, it should be 1 1/4. Let me clean that up. That's going to make it just a tad more interesting. The only thing that's going to change is right there. And then that's going to change what we do. Because we've already done a problem that had a mixed number. And we know with fractions, you have to multiply fraction times a fraction. So 1 1/4 is the same as 5/4 times 3/10. So what makes this a little bit more interesting is, yes, we do have a common factor that we can divide out. And we get 1/12 radical 3/8. Can I reduce 3/8? No. So the only thing I can try is to take the square root of the numerator and the square root of the denominator. So I actually have two options at this point, but I'm going to show you option one. If we have time for the second option, I'll show you. If not, remind me tomorrow and say, show us option 2 on that last problem in the notes. All right, what can I do to get rid of the radical 8? Because Rule 3 says no radicals allowed in the denominator. Okay? Ding.
Multiply the numerator denominator by square root of 8.
Yeah, I'm going to multiply top and bottom. And you know, you can say rad 8. Everybody knows what you're talking about. So you can multiply top and bottom by rad 8. And that gives you 1/12. And then I'm going to get in the numerator square root of 24. And I'm going to get in the denominator an 8. Okay. Unfortunately, we're breaking rule number 1.
Oh, no fraction.
No, fractions are fine as long as they're not completely under the radical. The problem is rule number 1 says you can't have perfect square factors other than 1 under the radical. There's a perfect square factor in 24. That's not 1. It's 4, right? So we're going to have to simplify this numerator. So we get 1/12 times 2. Oh, wait a second. This is supposed to be a 6. What am I thinking? We get 2 radical 6 over 8. Now we have to go back to basic fractions and look for a way to simplify our fraction. So remember how simplifying works? You can simplify anything from one numerator to any other denominator. So for example, 2 goes into itself once and into 12 6 times. What does that leave me? Well, 1 times radical 6, which is radical 6, and 6 times 8 is 48. That is your answer. Ooh, by the way, the book tends to write the answer this way, and they tend to pull the coefficient out in front. And if you don't have a number in the numerator, it's a 1. And then put the radical behind. So this is often how you'll see the answer is written the second way in the book. Okay? All right, we've got 1 minute. I can show you the other alternative. Okay? You know when we were back here and we had gone to this point? What you could have done is simplified here and made this radical 3 over 2 radical 2. And then you actually only needed to multiply top and bottom by radical 2. Oops. Oh, forget it. He doesn't want to play. All righty. We'll see you tomorrow. You got your homework.